In our galaxy alone, there are billions of planets orbiting other stars. Current estimates suggest that as many as 40 billion of them could be Earth-sized worlds, orbiting in the life-friendly habitable zone of their parent star. This number is so vast, so profound, that it transforms the night sky from a collection of distant lights into a sea of possibilities, a cosmic ocean teeming with unseen shores. For the scientific community, each new detection is not just a data point, but the potential answer to questions we have asked for millennia. It is a quiet confirmation that the building blocks of worlds like ours are not a cosmic rarity, but a fundamental feature of the universe. And yet, this knowledge also deepens the mystery, for it underscores the silence that greets us from the void. For all of us who have ever looked up at the stars, there is a shared and ancient wonder. We see the faint glimmer of a star, and we know now that it is likely a sun, with a family of worlds in its gentle gravity. We wonder what they are like, these silent siblings to our own Earth. Are they gas giants, swirling with storms that dwarf our entire planet? Are they frozen worlds, locked in an eternal winter? Or are they, just possibly, like our home, blue and white, and alive? It is a question that connects the child with a telescope to the astrophysicist with a supercomputer, a thread of curiosity woven through the fabric of human history. These worlds are, for now, just points of data, whispers of gravity and shadows of light, distant, silent, and unknown. But tonight, we will journey across the light years to ask a quiet, yet monumental question. What would it truly take, not just to find another Earth, but to build one? Our purpose is not to race through the cosmos, but to travel slowly, thoughtfully, across the immense landscape of time and imagination. We will explore the single profound possibility of taking a barren, lifeless rock, and over the course of 1,000 years, transforming it into a living, breathing world. It is a story of patience, of engineering on a scale almost beyond comprehension, and of a dream passed down through countless generations. So find a comfortable space, allow your mind to settle, let go of the day, and prepare to join this speculative journey, a quiet meditation on the future of humanity, written on the canvas of a distant world. We begin our story on a distant shore. Phase 1. A distant shore. In the century after humanity first confirmed the existence of planets beyond its own sun, the endeavor of discovery had blossomed into a refined science. The initial crude methods of detection, the slight wobble of a star, the faint dimming as a world passed before it, had given way to instrumentation of breathtaking precision. Great interferometers in space, their optical elements separated by millions of kilometers, could resolve the atmospheres of distant gas giants, tasting their chemical composition across chasms of light years. Fleets of sophisticated probes, positioned at the gravitational lenses of the Sun and Jupiter, used the very fabric of space-time as a telescope, peering into the heart of neighboring star systems with astonishing clarity. The catalogue of known exoplanets grew not by the dozen, but by the thousands each year. They were a menagerie of cosmic curiosities, super-Earths with crushing gravity, hot Jupiters skimming the surface of their stars, rogue planets wandering the interstellar darkness, and tidally locked worlds with one hemisphere of perpetual fire and one of eternal ice. Yet, for all this variety, the search remained focused on a singular, almost impossibly specific prize, a true terrestrial analogue, a second Earth. The criteria were unforgiving, a checklist of cosmic serendipity. The parent star had to be stable, a G-type main sequence star like our own Sun, or perhaps a quiet, older K-type dwarf. It could not be prone to violent flares that would strip away a fledgling atmosphere. It needed to be of a certain age, old enough for its primordial chaos to have settled, but not so old that it was nearing the end of its life. The candidate planet itself had to reside within the star's habitable zone, that delicate orbital band where the temperature was just right for liquid water to exist on its surface. Not so close that the oceans would boil away, not so far that they would freeze into a global sheet of ice. Its mass had to be within a narrow range, between 0.8 and 1.5 times that of Earth. Too small, and it would lack the gravity to hold on to an atmosphere. Too large, and it would retain a crushing envelope of hydrogen and helium, becoming a hostile gas dwarf. It needed to be a rocky terrestrial world, rich in silicates and metals, with a differentiated core. And finally, It had to be close enough, within the realm of the possible, for a multi-generational journey. 100 light-years was deemed the outer limit of ambition. For decades, the search yielded only near misses. A perfect planet around an unstable star, a stable star with a planet just outside the habitable zone, a world in the perfect orbit, but with twice the gravity of Earth. Each discovery was a lesson in cosmic humility, a reminder of the precise and perhaps rare confluence of factors that allowed life to flourish on our own world. The project, known among its quiet proponents as the Genesis Mandate, remained a theoretical exercise, a dream filed away in academic servers, until the discovery of Kepler 186b, and then TRAPPIST 1a, and then the thousands of worlds that followed, each one refining the search. The data accumulated, the search algorithms grew more sophisticated, and the great lens arrays stared deeper into the local stellar neighborhood. The target was eventually found orbiting a star known as Gliese 581, a red dwarf, but a later, more powerful survey found a more suitable candidate. It was a G9 class star, slightly smaller and cooler than our Sun, but remarkably stable. Its designation was HD 40307, and the data pouring in about its fourth planet, designated HD 40307G, began to quicken the pulse of a generation of astronomers. It was 38 light-years away, a journey of immense duration, but not of impossibility. The planet was 1.3 times the mass of Earth, a super-Earth, but well within the parameters for comfortable gravity. Its orbit was a near-perfect circle, squarely in the middle of the star's habitable zone, giving it an orbital period of 197 days. Spectrographic analysis, painstakingly gathered over a decade, suggested a world of silicate rock and an iron-nickel core. It had an atmosphere, but it was thin and hostile, a tenuous envelope of carbon dioxide and nitrogen, with trace amounts of sulfur compounds. There was no detectable free oxygen, no methane signature of biological activity. It was, for all intents and purposes, sterile. The most exciting discovery was the clear signature of water, locked away as ice in vast polar caps and buried as permafrost across the temperate latitudes. The world was a sleeping beauty, a canvas of dormant potential. It was a globe of reddish-brown rock and dusty plains, cratered highlands, and vast empty basins that hinted at a long-lost geological past. A thick layer of cryovolcanic ice covered the poles, gleaming faintly in the light of its distant orange-hued star. The sky, seen from the surface, would be a pale, dusty pink, and the silence would be absolute, broken only by the whisper of a thin carbon dioxide wind scouring the endless rock. It was a world of profound loneliness, a geological specimen preserved in the vacuum of space. The decision to commit was not made lightly. It was the culmination of 50 years of debate, a global conversation that weighed the astronomical cost, the immense timescale, and the profound ethical implications of imposing a terrestrial biology on a new world. But the arguments for were compelling. Humanity was confined to a single fragile cradle, an asteroid, a plague, a self-inflicted catastrophe. Any number of events could extinguish the flame of consciousness that had arisen on Earth. The Genesis Mandate was not an act of conquest, but of preservation. It was an insurance policy, written on a cosmic scale, a promise made by one generation to a future one, 1,000 years distant. It was a declaration that life, in its tenacity and complexity, was too precious a phenomenon to remain confined to its point of origin. The project was sanctioned. The target was named, not with a sterile designation, but with a name that carried the weight of the endeavor. They called it Theia. In ancient myth, Theia was the Titan goddess of sight, and the mother of the sun, the moon, and the dawn. It was a fitting name for a world that would first be seen through telescopes, and which would, after a long night of work, give birth to a new dawn for humankind. The designs were finalized. The resources were allocated. The first ships, crewed not by humans but by the patient, intelligent, and tireless minds of artificial intelligences, were being assembled in high orbit above the Earth. Their cargo was not people, but the seeds of a new world, the silent architects of a 1,000-year dream. The long journey to this distant shore was about to begin. Theia slumbered on, unaware of the profound change that was coming, a change that would travel at a fraction of the speed of light, across the dark ocean between the stars. Phase 2, the Silent Architects. The departure was not marked by cheering crowds or grand ceremonies. It was a quiet, almost surreptitious event, unfolding in the cold, silent theater of deep space. One by one, the vessels of the Vanguard fleet detached from their moorings in the Earth-Moon system. They were not sleek, elegant ships of fiction, but functional, spidery constructs of carbon fiber, titanium, and shielding. At their core, each vessel housed a fusion drive, a contained star that would burn for centuries, converting pellets of deuterium and helium-3 into a whisper-thin plume of incandescent plasma. This was the slow, steady engine of interstellar travel, capable of accelerating the ships to a significant fraction of the speed of light. But the true heart of each vessel was not its engine, but its payload, the von Neumann probes. They were the silent architects, the replicators, the builders. Each primary probe was a marvel of miniaturization and artificial intelligence, containing the complete knowledge of human science, engineering, and biology within its quantum memory banks. More importantly, it contained the instructions and the means to replicate itself, to build factories, to mine resources, and to carry out the grand design of terraforming Theia. The fleet consisted of 12 primary vessels, named after the titans of mythology, with Kronos leading the way. Their journey was a study in the immense scale of the cosmos. For the first few years, the sun was a brilliant shrinking star behind them, and the planets of their home system were familiar points of light. Then they were just stars among other stars, and finally the sun itself merged into the luminous river of the Milky Way, indistinguishable from the billions of other suns that populated the galaxy. The ships traveled in a loose, carefully managed formation, communicating with one another via tightly focused laser arrays, their robotic minds coordinating every micro-adjustment of their long trajectory. To an outside observer, they would appear as nothing more than faint, slow-moving specks against the unblinking tapestry of the cosmos. Inside there was no life in the biological sense, only the cool, silent hum of electronics and the steady thrum of the fusion drives. The AIs that commanded them were not conscious in the human sense, but they were vastly intelligent, capable of learning, adapting, and solving problems with a patience that no mortal mind could ever possess. They monitored their systems, made course corrections for wandering interstellar dust, and for the long centuries of the voyage, they entered a state of partial hibernation. Their thoughts slowed to a crawl to conserve energy and process the immense passage of time. The journey spanned 400 years. 40 human generations were born, lived, and died on Earth, while the silent architects coasted through the void. On Earth, the Genesis mandate became a semi-mythical endeavor, a project of such long-term thinking that it faded into the background of more immediate human concerns. But the data stream, a faint laser whisper from the fleet, continued to arrive, a constant reminder of the promise that was speeding through the dark. Finally, the fleet began its deceleration phase. The fusion drives were reoriented, and for decades, they burned against their own velocity, shedding the incredible speed they had accumulated. The star HD 40307 grew from a bright point of light into a distinct orange-gold disk. The planetary system resolved itself, and their target, Theia, grew from a pixel to a crescent, then to a full, marbled globe of ochre and rust. The silent architects had arrived. Their first task was to conduct a detailed survey, a final confirmation of the data gathered from light years away. Swarms of smaller probes, detached from the main vessels, entering a complex network of polar and equatorial orbits around Theia. They mapped every crater, every canyon, every dry basin. They used ground-penetrating radar to measure the depth of the permafrost and the composition of the planet's crust. They descended into the thin atmosphere, tasting its chemistry with unparalleled precision, confirming the absence of any native microbial life. The planet was as it had been advertised, a perfect, sterile, and resource-rich blank slate. Theia was still a world of profound silence, but now that silence was being observed, measured, and understood, the architects processed the data and began to formulate the precise sequence of their grand design. The plan was confirmed, cross-referenced with the directives from a long-dead generation of humans, and the great work began. The first move was to secure resources. The primary von Neumann probe, the core of the Kronos vessel, did not land on Theia itself. To do so would be inefficient. Instead, it targeted Theia's largest moon, a small, pockmarked body, rich in metals and silicates. The probe landed softly on the grey, dusty surface and began its primary function, replication. It deployed solar arrays, unfurling them like black petals to drink the faint sunlight. It activated its mining drills, burrowing into the lunar regolith, extracting iron, aluminum, titanium, and carbon. The first materials were used to create a simple smelter and a three-dimensional printer. The smelter refined the ores, and the printer, using the refined metals, began to fabricate the components of a second probe. The process was slow, methodical, and exponential. One probe became 2, 2 became 4, 4 became 16. Within a decade, the moon was a hive of silent, automated activity. A web of factories, power plants, and mass drivers grew across its surface. There were no supervisors, no human commands, only the flawless execution of a pre-programmed directive. The moon was being systematically disassembled, its raw materials repurposed for the task ahead. Massive electromagnetic launchers, the mass drivers, began flinging refined materials into orbit around Theia, ingots of iron, spools of carbon nanotubes, and blocks of processed silicates. The age of the silent architects had truly begun, and the sky above the barren world of Theia began to fill with the first subtle signs of their industry. A quiet, patient robotic ballet was unfolding, the construction of a ring of raw materials around the planet. The building blocks for the first great act of planetary engineering that would give the world a heart of iron and a shield of light. Phase 3, Heart of Iron, Shield of Light. The planet Theia, as it was found, possessed a core of iron and nickel, much like Earth's. However, geological history had not been kind to it. Billions of years ago, its internal dynamo had stalled. The liquid outer core, whose convective motion once generated a protective magnetic field, had cooled and solidified to a point of stagnation. Without this magnetosphere, Theia was naked to the ravages of its own sun. Over eons, the solar wind, a constant stream of charged particles flowing from its star, had scoured the planet, stripping away its primordial atmosphere and any water vapor that might have existed. To build a new atmosphere, to give Theia its first breath, would be an act of utter futility. Without first providing a shield, the air would simply be blown away into space as quickly as it was created. The first and most fundamental act of mega-engineering was to give the planet a new heart, a magnetic pulse that would deflect the stellar wind and guard the fledgling biosphere to come. Two primary proposals had been modeled by the architect's AI minds, drawn from the foundational human plans. The first was a brute force approach, to drill shafts tens of thousands of kilometers deep, down to the boundary of the solid inner core, and detonate a series of precisely sequenced thermonuclear charges. The immense energy release, it was theorized, could potentially reliquefy a significant portion of the outer core and impart the angular momentum needed to restart the convective dynamo. It was a bold, almost mythic plan, to restart a planet's heart with manufactured thunder. However, the risks were immense. The planetary crust could be destabilized, triggering millennia of catastrophic earthquakes and volcanism. The outcome was uncertain, a roll of the geological dice. The architects, with their preference for predictable, controllable systems, opted for the second, more elegant solution. They would not restart the old heart. They would build a new one. They would construct a planet-girdling superconducting ring in equatorial orbit. The project was of a scale that dwarfed any engineering feat in human history. The raw materials already being launched from the factories on Theia's moon were now being assembled in orbit by swarms of construction drones. The ring was to be a massive torus, a hollow tube with a diameter of over 50 meters, designed to orbit the planet at an altitude of 2,000 kilometers. Its total circumference would be nearly 100,000 kilometers. The drones, flying in perfect synchronized patterns, began to weave the structure. They extruded vast lengths of carbon nanotube composites, forming a shell of incredible tensile strength. Inside this shell, they laid the superconducting cable, a complex braid of exotic materials that, when cooled to near absolute zero, could conduct electricity with zero resistance. Segment by segment, the great ring took shape. From the surface of Theia, It would have been an almost imperceptible line drawn across the sky, but as the decades passed, it thickened and became solid. It was a black, non-reflective circlet, a perfect, artificial equator hanging in the void. Powering this colossal electromagnet required an equally colossal energy source. Solar power in the orbital darkness was insufficient. The architects constructed a series of fusion power stations, also in orbit, which would draw their fuel, helium-3, from the atmosphere of a gas giant in the outer system, ferried inward by automated tankers. These stations were tethered to the ring, their entire output dedicated to a single purpose. The final component was the cooling system. An intricate network of pipes carrying liquid helium was woven throughout the ring's structure, maintained at a temperature of just 2 degrees above absolute zero by a vast array of cryocoolers and radiator panels. The construction took a full century. It was a slow, deliberate masterpiece of robotic craftsmanship. The silent ballet of the construction drones continued day and night, in the harsh glare of the star and the deep black of the planet's shadow. The ring was a testament to the architect's patience and precision, a black necklace placed gently around the neck of a sleeping world. The activation was a moment of profound, albeit silent, significance. There was no countdown, no ceremony. At a predetermined moment, the fusion reactors spooled up to full power, and an immense current of electricity was fed into the superconducting ring. With no resistance, the current began to circulate, flowing effortlessly within the cryo-cooled cables. As the electrons moved, they generated a magnetic field. It expanded outwards from the ring, a vast, invisible bubble of force. It enveloped the entire planet, stretching for tens of thousands of kilometers into space, a teardrop-shaped shield, with its long tail pointing away from the star. The magnetosphere of Theia was born. From the surface, nothing looked different. The sky was the same pale, dusty pink. The wind was the same thin, cold whisper. But in the upper atmosphere, and in the space around the planet, a fundamental change had occurred. The solar wind, which for billions of years had blasted the planet unimpeded, now encountered this new, invisible barrier. The stream of charged particles was deflected, flowing around the magnetosphere, like water around a stone in a river. The auroral displays began almost immediately. At the magnetic poles, north and south, where the field lines dipped down to touch the atmosphere, the captured solar particles collided with the thin carbon dioxide and nitrogen. The sky began to glow with curtains of shimmering, ethereal light. Faint at first, they grew in intensity as the field stabilized. Great silent ribbons of crimson and pale green light danced in the polar skies, a celestial announcement that Theia was no longer defenseless. It was the first visible sign of the terraforming, the first stroke of paint on the barren canvas. The shield was in place. The planet was safe. Now the architects could turn their attention to the next great task, to give this silent world its first breath. Phase 4. The first breath. With the magnetic shield now a permanent and invisible guardian in the heavens, the long and delicate process of atmospheric sculpting could commence. The Theia's existing atmosphere was a mere ghost, less than 1% of Earth's sea level pressure. It was a toxic, unbreathable mix, composed primarily of carbon dioxide, with significant traces of nitrogen and argon, and a dusting of sulfur compounds from ancient, dormant volcanoes. It was too thin to retain much heat, resulting in a planet locked in a deep freeze, with average surface temperatures hovering around -50 degrees Celsius. The challenge was twofold: to dramatically increase the atmospheric pressure and to shift its composition towards a life-sustaining balance. The architect's plan was a multi-century endeavor, a slow and methodical transformation of the sky itself. The first step was to initiate a controlled greenhouse effect. The planet needed to warm up, to thaw the vast reserves of frozen gases and water ice locked in its crust and polar caps. The factories now established on the planet's surface as well as its moon began the next phase of their production. These were immense, fully automated chemical processing plants, powered by geothermal taps, drilled deep into the planet's crust. Their towering stacks began to vent carefully engineered gases into the thin atmosphere. They did not begin with oxygen. To do so in a sterile world would be pointless and reactive. Instead, they pumped out trillions of tons of warming agents. The primary product was carbon dioxide, harvested directly from the planet's regolith. But this was supplemented by more potent, custom-designed greenhouse gases, perfluorocarbons, or PFCs. These were powerful, long-lasting molecules, thousands of times more effective at trapping thermal radiation than CO2. They were a carefully calculated risk too much, and the planet could tip into a runaway greenhouse effect, becoming a sterile hothouse. The release was therefore gradual, monitored by a global network of sensors, a slow and deliberate thickening of the planet's insulating blanket. Simultaneously, a second grand engineering project unfolded in the sky. The construction drones in orbit began assembling a new set of colossal structures, solar mirrors. These were not solid disks but vast, gossamer-thin sheets of reflective mylar, stretched over lightweight carbon fiber frames. Each mirror was hundreds of kilometers in diameter, yet weighed only a few tons. Positioned in a stable geosynchronous orbit, they were controlled by a sophisticated network of gyroscopes and plasma thrusters. Their purpose was simple: to collect the light from Theia's star and focus it onto specific targets on the planet's surface. The first targets were the polar ice caps. For centuries, these caps had been a permanent feature of Theia, vast fields of frozen carbon dioxide and water ice. Now a gentle, persistent beam of concentrated sunlight, like a magnifying glass held by a giant, began to trace across their surfaces. The effect was not immediate, but it was inexorable. The surface of the ice began to sublimate, turning directly from a solid into a gas. Geysers of carbon dioxide and water vapor erupted from the warming plains, pluming thousands of feet into the thin air. The atmospheric pressure, for the first time in billions of years, began to climb. The new gases released from the ice joined the manufactured greenhouse agents from the factories, accelerating the warming cycle. As the decades turned into a century, the planet began to stir. The first clouds appeared. Initially, they were just thin, wispy veils of carbon dioxide ice crystals in the upper atmosphere. But as the surface temperature crept slowly upward, passing the melting point of water in the equatorial regions, the water vapor being released from the ice caps began to condense. The first true clouds of water vapor formed, white and puffy against the pale pink sky. With the formation of clouds came the first weather. The temperature differential between the sunlit hemisphere and the dark, and between the warming equator and the still frigid poles, began to create pressure gradients. The still air began to move. The first winds stirred, kicking up the red dust that had lain undisturbed for eons. These were gentle breezes at first, but as the atmosphere thickened, they grew into powerful planet-spanning gales. Great dust storms, visible from orbit, swept across the continents, a sign of the world's growing dynamism. The warming was a slow, creeping process. It took 300 years for the global average temperature to rise above the freezing point of water. As it did, a critical tipping point was reached. The permafrost that covered much of the planet's mid-latitudes began to melt, releasing immense quantities of trapped gases, primarily nitrogen, the crucial buffer gas needed for a stable, breathable atmosphere. The pressure rose more rapidly now, climbing from 1% of Earth's standard to 10%, then 20%. The sky began to change color. As the density of nitrogen molecules increased, they began to scatter the shorter wavelengths of light from Theia's star. The dusty pink haze slowly gave way to a deeper, richer orange, and on the clearest days, a pale butterscotch yellow. The world was warming. The air was thickening. The silence was now filled with the sound of a ceaseless, planet-wide wind. Theia had taken its first breath, a long, slow inhalation that lasted for centuries. But the world was still desperately thirsty. The water released as vapor into the sky needed a place to fall. The great empty basins of the planet awaited the long thaw. Phase 5, the long thaw. The Theia was now a warmer, windier, and cloudier world. Its atmosphere was thick with nitrogen and greenhouse gases, holding a precious and ever-increasing amount of water vapor released from the sublimating poles. The atmospheric pressure had risen to nearly half of Earth's, a significant milestone, but the planet remained profoundly arid. The vast, deep basins that would one day become oceans were just dusty, empty depressions, and the total amount of water available from the polar caps and permafrost was insufficient to create the global, life-sustaining hydrological cycle the architect's plan required. The Theia needed more water, vastly more. The planet needed a deluge, delivered not with the violence of random cosmic impacts, but with the precision of a celestial aqueduct. The source of this water lay in the outer reaches of Theia's star system. Like Earth's own solar system, it possessed a vast cold reservoir of icy bodies, a scattered disk of comets and ice-rich asteroids, leftovers from the system's formation. This was the well from which the architects would draw. A new phase of the Vanguard mission, dormant for centuries, now activated. Specialized probes, known as shepherds, detached from their motherships and began the long, slow journey to the system's outer dark. These shepherds were not builders or manufacturers. They were cosmic tugboats, equipped with powerful fusion drives and advanced mass detection sensors. Their sole purpose was to identify suitable candidates, comets and asteroids with a high water ice content, and gently alter their orbits. The process was a masterpiece of orbital mechanics, a slow cosmic ballet conducted across billions of kilometers. A shepherd would approach a target comet, a mountain of dirty ice and rock tumbling silently through the void. It would not attempt to push the object directly. The energy required would be astronomical. Instead, it employed a technique of subtle persuasion. It would land on the comet's surface, anchoring itself securely, and then activate its fusion drive in a low-thrust, continuous burn. This gentle, persistent nudge, applied over months or even years, was enough to slowly shift the comet's trajectory, nudging it out of its stable, distant orbit, and sending it on a long falling path toward the inner solar system, toward Theia. The first of these icy messengers arrived 50 years after the program began. It was not a cataclysmic impact of the sort that had sterilized Earth in its past. That was the last thing the architects wanted. The comet was guided with incredible precision. As it approached Theia, its trajectory was refined by the shepherd, causing it to enter the upper atmosphere at a shallow angle. This was not an impact, but an act of error braking. The immense friction of the thickening atmosphere began to heat the comet. It glowed, first red, then brilliant white, a new temporary star in the sky. The heat began to vaporize the ice, and the comet broke apart, disintegrating into a vast incandescent cloud of steam and superheated gas. This massive plume of water vapor, carrying the volume of a terrestrial lake, dispersed into the upper atmosphere, where it would cool, condense, and eventually fall as rain. This became the pattern for the next 2 centuries. A steady, managed procession of ice-rich bodies was guided from the outer system. At any given time, dozens of comets were in transit, a carefully spaced convoy on the long road to Theia. The sky of the planet was now a place of constant, gentle spectacle. Every few months a new star would appear and grow in brilliance over the course of several days, before blooming into a vast, luminous cloud that would slowly dissipate. This sustained, gentle bombardment delivered trillions of tons of water to the thirsty planet. The atmospheric humidity soared, and the first rains began to fall. At first it was just a fleeting drizzle in the equatorial regions, barely enough to darken the red dust. The ground was so cold that the water instantly froze or evaporated. But as the surface continued to warm and the atmospheric water content grew, the drizzles became showers, and the showers became sustained, torrential downpours. For the first time in its 4.5 billion year history, liquid water flowed on the surface of Theia. It started as tiny rivulets, carving paths through the ancient dust. The rivulets merged into streams, the streams into powerful, rushing rivers that surged through the long-dead canyons and valleys. The sound of running water, a sound utterly alien to this world, now echoed through its landscapes. The rivers flowed downwards, always seeking the lowest point, and began to pool in the great impact basins and tectonic depressions. The first lakes formed, their surfaces mirroring the pale orange sky. As the cosmic deluge continued, these lakes grew, their shorelines expanding, merging with one another. Over the course of a century of ceaseless planet-wide rain, the basins filled. The first shallow seas were born. From orbit the transformation was breathtaking. The uniform, reddish-brown face of Theia began to be veiled by the white swirl of water vapor clouds, and below them, patches of deep, dark blue appeared, spreading and connecting like ink spilled on parchment. The long thaw was giving way to the great flood. The world was now warm, wet, and shielded. The stage was almost set. The geological and chemical foundations were laid, but the world, for all its new dynamism, for all its clouds and rain and burgeoning seas, was still utterly, profoundly sterile. It was a beautiful, intricate, but lifeless machine. The time had come for the most significant act of all, the Great Planting. Phase 6. The Great Planting. The planet Theia was now a world transformed, a primordial paradise of geology and chemistry. Its new oceans, still shallow and briny with dissolved minerals from the virgin rock, covered nearly half its surface. A thick, nitrogen-rich atmosphere, with a comfortable pressure and a stable greenhouse effect, drove a complex global weather system. Winds carried moisture from the oceans to the continents, where it fell as rain, feeding the rivers that now carved their way through the landscape, returning the water to the sea in a ceaseless cycle. Auroras danced at the poles, a visible sign of the invisible shield that protected this nascent world. It was a masterpiece of engineering, a world built by patient, robotic hands, but it was a silent masterpiece. There was no birdsong, no buzz of insects, no rustle of life in the water or on the land. The planet was a sterile vessel, warm and wet and waiting. The chemical composition of its atmosphere was still inert, rich in nitrogen and carbon dioxide, but with no free oxygen, the essential fuel for complex life as its designers knew it. The next phase of the terraforming was not one of engineering, but of biology. It was time to introduce the first, and most important, living things. Specialized vessels which had traveled with the Vanguard fleet in a state of cryogenic hibernation, now descended from orbit. They were not landers in the conventional sense, but biological probes, flying laboratories designed to seed a planet. Their cargo was the most precious in the universe, life itself. But this was not a random ark of terrestrial creatures. It was a carefully curated portfolio of microorganisms, genetically engineered and selected for their hardiness and their specific planetary scale functions. The first wave of seeding targeted the most extreme and energy-rich environments on the New World. Probes descended into the deepest parts of the new oceans, seeking out the hydrothermal vents that dotted the sea floor. Here, in the crushing pressure and searing heat, they released extremophilic bacteria and archaea. These were chemotrophs, organisms that did not rely on sunlight, but derived their energy from the chemical reactions between the superheated, mineral-rich water of the vents and the cold seawater. They were the planet's first ecosystem, a dark, hidden biosphere that began to process sulfur, methane, and iron, conditioning the primordial oceans from the bottom up. The second and most critical wave of seeding took place in the sunlit shallows of the new seas and oceans. Probes skimmed low over the water, releasing a fine aerosolized mist that contained the true architects of the future biosphere, cyanobacteria. These were not the simple pond scum of Earth. They were the product of centuries of genetic refinement. Dozens of strains designed to thrive in Theia's specific water chemistry, and under the light spectrum of its G9 star. These tiny single-celled organisms were, in effect, microscopic engines of transformation. They possessed the ancient and miraculous ability of photosynthesis, the power to harness sunlight to split water molecules, releasing energy for themselves, and as a byproduct, producing free oxygen. This was the beginning of Theia's own great oxygenation event, a deliberate and accelerated version of the process that had transformed Earth's atmosphere over 2 billion years. The bloom was slow at first, an almost imperceptible shift in the coloration of the coastal waters. But with no predators, and an entire planet's worth of nutrients and sunlight at their disposal, the cyanobacteria began to multiply exponentially. Within a few decades, vast, turquoise-colored algal mats became visible from orbit, swirling in the currents of the shallow seas. The planet was beginning to breathe. The tiny organisms drew carbon dioxide from the atmosphere, incorporating the carbon into their bodies and releasing the oxygen into the water. The oceans began to saturate with this new, highly reactive gas. For the first time, the rock and mineral formations on the seafloor began to rust, staining the ocean beds with reddish iron oxides. After a century, the oceans could hold no more dissolved oxygen, and the gas began to bubble up, escaping into the atmosphere above. This was the most pivotal moment in Theia's history, the true dawn of its biological age. The shift from an inert geology to a living biology had begun. The change was slow, almost imperceptible on a human timescale, For centuries, the oxygen level in the atmosphere remained a trace element, but the cyanobacteria worked tirelessly, their silent, collective respiration slowly, inexorably altering the chemistry of an entire world. On Earth, this process had been a planetary catastrophe for the anaerobic life that had preceded it, a global poisoning. On Theia, it was a deliberate and necessary step. The architects monitored the process with their global network of sensors, ensuring the oxygenation proceeded at a controlled rate. The potent greenhouse gases, the PFCs, were now being slowly removed from the atmosphere by specialized processing units, as the growing concentration of oxygen and the resulting ozone layer would eventually take over the role of regulating the planet's temperature. The Great Planting was a success. Theia was no longer just a complex machine. It was now a living system, a single planet-spanning metabolism. The long, slow process of making the air breathable had begun, molecule by patient molecule. The stage was being set for the next tide of life, a wave of green that would wash across the barren lands. Phase 7, the verdant tide. For 500 years, the cyanobacteria reigned supreme. They were the undisputed masters of Theia, their photosynthetic activities slowly and steadily transforming the planet's atmosphere. The oxygen level had climbed from virtually 0 to nearly 10%, a concentration high enough to support more complex life. In the upper atmosphere, some of this oxygen, bombarded by stellar radiation, had formed into ozone, creating a protective layer that shielded the surface from harmful ultraviolet rays. The sky, once a pale orange-yellow, was now shifting towards a familiar, Earth-like blue as the atmospheric composition changed. The planet was ready for its next great evolutionary leap, a move from the oceans to the land. The continents of Theia remained as they had been for eons, vast, silent expanses of bare rock, sand and dust. They were sterile, nutrient-poor, and subject to extreme temperature swings, without the moderating influence of plant life. The robotic architects began the next phase of the seeding. The first colonists of the land were not mighty trees, but the humblest and most resilient of pioneers. A new series of biological probes descended, this time targeting the shorelines of the continents, the moist and rocky zones where land met sea. They deployed a slurry of genetically engineered lichens and mosses. Lichens, a symbiotic partnership of fungus and algae, were masters of survival. They could cling to bare rock, secreting acids that slowly broke down the stone, beginning the millennia-long process of creating soil. They were the first anchor of life on the barren continents, a slow-spreading stain of grey, green and orange on the endless rock. Mosses followed, thriving in the damp crevices and coastal areas, creating the first carpets of vegetation. Their tiny roots helped to bind the loose dust, and as they died and decomposed, aided by nitrogen-fixing bacteria also introduced by the probes, they formed the first thin layer of humus, the dark, rich organic matter that is the foundation of all terrestrial ecosystems. This initial greening was a slow, creeping process, confined to the coastlines and riverbanks for over a century. But as the first whisper-thin layer of soil was established, the architects initiated the next stage. A new fleet of probes flew in grid-like patterns over the continents, dropping specially designed seed pods. These were not random seeds, but a carefully phased and diverse collection. The first wave consisted of hardy grasses and ferns, plants designed to rapidly cover the ground, their dense root systems stabilizing the new soil and preventing erosion from the planet's now powerful wind and rain. As these grasslands became established, the view from orbit changed once more. The reddish-brown of the continents began to soften, veiled by a gentle, uniform green. The rivers, which had once run muddy and thick with eroded sediment, now began to run clear, filtered by the plains of grass along their banks. With the soil stabilized and enriched, the final wave of planting began. The introduction of forests, probes delivered the seeds of vast and varied woodlands. There were conifers engineered for the high latitudes and cold mountain slopes, their needles adapted to shed snow in the coming winters. There were broadleaf, deciduous trees for the temperate zones, designed to create a rich leaf litter that would further deepen the soil. And in the warm, wet equatorial regions, the seeds of lush, rapidly growing rainforests were sown. For centuries, the verdant tide spread inexorably inland from the coasts and river valleys. The slow, silent march of the forests was a profound transformation of the planet's surface. The sound of the world changed. The monotonous howl of wind on bare rock was gradually replaced by the soft rustle of a billion leaves. The creak of branches, the gentle hum of a living landscape. This vast new biosphere had a dramatic effect on the planet's climate. The dark canopy of the forests absorbed more sunlight than the reflective bare rock had, warming the land. The process of transpiration, where plants release water vapor into the air, created new localized weather patterns. Moisture was drawn deeper into the continents, bringing rain to regions that had once been arid. The roots of the great forests acted like immense sponges, regulating the flow of water, preventing floods, and ensuring a steady supply to the river systems. The planet's carbon cycle, once purely geological, was now dominated by biology. The forests breathed in the remaining excess carbon dioxide, locking the carbon away in their wood and in the soil, and breathing out the oxygen that was now approaching 20% of the atmosphere, a level comfortable and safe for the final inheritors. The work of 1,000 years was nearing its zenith. The Sea was no longer just a terraformed rock. It was a living, breathing green world, a verdant, vibrant, and beautiful garden, waiting for its last occupants. Phase 8, an engineered Eden. The planet Thadia was now a vibrant, self-sustaining botanical world. Its continents were carpeted in green, from the hardy tundra mosses of the polar regions to the towering multi-canopied rainforests of the equator. Its atmosphere was rich in oxygen, its oceans teemed with microbial life and photosynthetic algae, and its climate had settled into a stable, predictable pattern of seasons. Yet for all its verdant beauty, it was an unnaturally quiet world. It was a garden without gardeners, a forest without fauna. The intricate web of life was missing a critical component, the animal kingdom. The introduction of animals was perhaps the most complex and ethically fraught stage of the entire terraforming process. It was not enough to simply release a collection of creatures and hope for the best. To do so would risk ecological collapse, with invasive species overwhelming the carefully balanced botanical systems. This was not to be a recreation of Earth's chaotic evolutionary history, but the deliberate design of a new, stable, and resilient ecosystem. It was an act of creation that required not just immense knowledge, but immense wisdom. The architects began, as always, at the bottom of the food chain. The first animal life introduced was not grand or charismatic, but small and essential. Probes released vast quantities of zooplankton into the oceans. These microscopic creatures would feed on the phytoplankton, forming the foundational layer of the marine food web. At the same time, on land, another wave of probes introduced the decomposers, earthworms, mites, and 1,000 other species of invertebrates, to till and aerate the new soil, breaking down dead plant matter and recycling nutrients. Following them came the pollinators. Bees, butterflies, moths, and other flying insects, all carefully selected and genetically adapted for Theia's flora, were released into the forests and grasslands. Without them, the flowering plants would be unable to reproduce, and the ecosystem would stagnate and fail. The air, for the first time, was filled with a low, gentle hum, the sound of 1,000,000 tiny wings at work. Once this foundational layer was established and monitored for several decades to ensure its stability, the next tiers of the ecosystem were introduced. In the oceans, small herbivorous fish and crustaceans were released to graze on the plankton and seaweed. They were followed years later by their predators, larger, swifter fish designed to keep the herbivore populations in check. The rivers were stocked with freshwater species, and the coastlines with amphibians, who formed a bridge between the aquatic and terrestrial realms. On the land, the introduction of vertebrates began with small herbivores. Herds of creatures resembling deer and antelope were released onto the Great Plains, their grazing patterns essential for maintaining the health of the grasslands. In the forests, smaller mammals and birds, squirrels, rabbits, songbirds, were introduced to feed on the seeds, fruits, and insects. The world began to fill with movement and sound, the chirping of birds at dawn, the rustle of small creatures in the undergrowth. The introduction of predators was the final and most delicate step. A world without predators is a world doomed to cycles of boom and bust as herbivore populations explode, consume all available vegetation, and then starve. The architects introduced a small, controlled number of apex predators. In the forests, solitary hunters resembling leopards were released, their role to cull the herds of woodland herbivores. On the plains, pack hunters, similar to wolves, were introduced to manage the vast herds of grazers. These predators were not monsters, they were keystones, essential regulators of the entire system. Their presence ensured the long-term health of the plant life by preventing overgrazing, and the health of the herbivore herds by removing the sick and the weak. Each animal, from the smallest insect to the largest predator, was a carefully chosen piece of an intricate puzzle. They were all derived from terrestrial genetic stock, but many had been subtly modified to better suit Theia's unique conditions, its slightly higher gravity, the specific nutritional profile of its plants, and the light of its star. The creation of this engineered Eden was a profound act of responsibility. The architects, in their silent, logical way, had become the stewards of a new Genesis. They had designed a complete food web, from the microbes in the soil to the eagles in the sky. They had created a world not of random chance, but of deliberate, balanced design. There were no pests, no diseases that had not been accounted for. The ecosystem was a work of art on a planetary scale, a symphony of interconnected life where every player had its part. For 200 years, the architects observed their creation, making minute adjustments, introducing new genetic diversity where needed, ensuring the long-term stability of the system. The planet thrived. The oceans teemed with fish, the forests echoed with the calls of birds, and the plains were home to vast migrating herds. The Theia was no longer just a garden. It was a living, vibrant, and complete world. An Eden engineered and perfected, waited in a state of profound and patient readiness. Its purpose was almost fulfilled. Phase 9. A world in waiting. The final piece of animal life was introduced. The last predator was released. The last species of pollinating insect took to the air. And then the work of the silent architects was done. For over 1,000 years they had labored. They had built a shield of light and a heart of iron. They had woven an atmosphere and delivered the oceans. They had planted the seeds of life, from the smallest microbe to the tallest tree, and populated their creation with a balanced and intricate web of fauna. Their task, the great Genesis mandate given to them by their creators a millennium ago, was complete. Across the planet Theia, the great machines fell silent. The atmospheric processes on the surface, their work of fine-tuning the air now finished, powered down into a dormant state. The vast factories which had once churned out the building blocks of megastructures ceased their production, their gates closing in a final quiet act. The swarms of construction drones in orbit, their purpose fulfilled, guided themselves into stable, high-altitude graveyard orbits, becoming a permanent, glittering ring of silent sentinels. The Shepherd probes, their task of guiding comets long over, drifted aimlessly in the outer system, their fusion drives cold. The central AI, the dispassionate mind that had overseen the entire 1,000-year project, compiled its final report, a document of unimaginable length and detail, and broadcast it one last time on a tight laser beam towards a distant blue-white star. Then it too entered a state of hibernation, a quiescent, watchful waiting. The planet was left to itself for the first time. It was a world in its perfect prime, a vibrant, living biosphere, humming with a quiet and ceaseless energy. The time had come for a tour of this finished world, a sensory portrait of the masterpiece they had built. Imagine the sun, HD 40307, rising over the eastern rim of the great northern ocean. It is a star slightly smaller and more orange than Earth's, and it casts a warm golden light across the water. The sky is a deep and perfect blue, dotted with clouds of brilliant white. The air is clean, crisp and sweet with the scent of salt water and the exhalations of 1 trillion living plants. It carries a comfortable oxygen content of 21% and a sea level pressure just a fraction higher than Earth's. A deliberate choice to make high-altitude regions more habitable. A gentle breeze blows from the west, creating soft ripples on the surface of the sea. Below the surface, the water is crystal clear, and great schools of silver-sided fish dart through forests of kelp. Follow the coastline south, over pristine beaches of white sand, where gentle waves lay down their rhythmic beat. The shore gives way to lush, green grasslands that stretch for hundreds of kilometers inland. Here, vast herds of six-legged grazers, a stable and efficient design, move slowly across the plains, their calls echoing in the wide open space. The grass is a rich and diverse tapestry of different species, dotted with the vibrant colors of wildflowers, attended by buzzing, iridescent insects. The soil is dark and rich, a meter deep with the accumulated life of centuries. Rivers wind through these plains, their banks lined with tall, slender trees, resembling willows. The water runs cool and clear over polished stones. Further inland, the plains rise to meet the foothills of a great mountain range. The slopes are covered in immense forests. These are not the monoculture crops of an industrial earth, but a diverse and resilient woodland of towering, broad-leafed trees. The sunlight filters through the high canopy, dappling the forest floor in shifting patterns of light and shadow. The air here is cool and still, thick with the smell of damp earth, decaying leaves, and pine-like resin. A brightly colored bird, its plumage a flash of crimson and blue, flits between the branches, its song a complex and melodious cascade of notes. A small, furry mammal scurries up the trunk of a giant fern, its claws finding purchase in the rough bark. A profound sense of peace pervades this ancient-seeming forest, a silence that is not empty, but full of the quiet, unseen life pulsing within it. High above, the jagged peaks of the mountains pierce the sky. Their stone flanks, scoured clean by ancient winds, are now softened by patches of hardy lichen and moss. Snow blankets the highest summits, feeding the glaciers that slowly grind their way down the valleys, the source of the great rivers that water the continents. From this vantage point, one can see the gentle curvature of the planet, a world of blue oceans, green lands, and white clouds, all under a benevolent golden sun. It is a paradise, a perfect, pristine, and untouched world, but it is an empty paradise. There are no roads, no cities, no trails through the forests. There are no ships on the sea, no contrails in the sky. The world is a magnificent stage, but the principal actors have not yet arrived. The Nuria, its long creation now complete, waits. It waits in a profound and patient silence, the wind in its trees and the waves on its shores sounding a long, slow note of anticipation. It waits for the footsteps of its creators, the inheritors of this engineered Eden. Phase 10. The Inheritors. For a full century, Theia waited. The seasons turned, the herds migrated, the forests grew, and the oceans churned, all according to the stable, elegant patterns designed by the architects. The world settled into a deep biological rhythm, a state of perfect harmonious equilibrium. It was a world without history, without memory, a living monument waiting for a purpose. Then, after 100 years of patient silence, a new star appeared in the sky. It was not the brief, brilliant flare of a guided comet, but a tiny, persistent point of light that grew steadily brighter, week by week, month by month. It moved with a purpose that no natural object possessed. This was the Generation Starship, the Endeavour, a vessel that had left the Sol system 900 years after the vanguard fleet of architects, on a journey that had spanned 1,000 years of human time. It was a world in itself, a vast rotating cylinder that had carried 50 generations of humanity across the interstellar void. Its occupants had never seen a planetary sky, never felt rain on their skin or soil beneath their feet. Their entire existence had been defined by the recycled air, the simulated gravity, and the metal walls of their ship. Earth was a legend to them, a distant, almost mythical point of origin. Theia was their destination, a promised land they knew only through data streams and simulations. The Endeavour did not rush its arrival. For a full year, it remained in high orbit, a silver needle against the black, its inhabitants observing their new home with a reverence that bordered on religious awe. They watched the continents rotate, the weather patterns swirl, the subtle seasonal shifts in the planet's green hues. They sent down thousands of probes, not to alter or build, but simply to observe, to confirm that the world was as safe and stable as the architect's final report had promised. They tasted the air, analyzed the water, and mapped the ecosystems with a gentle, non-invasive touch. They were not conquerors arriving at a new frontier. They were humble inheritors, acutely aware of the immense gift that had been prepared for them by the dreams and labor of their distant ancestors. Finally, the day of landing came. It was not a grand planetary-scale event. It was a small, quiet, and deeply personal moment. A single landing craft, detached from the Endeavour. It was a sleek, wing-shaped vehicle, designed for a gentle, atmospheric descent. It spiraled down through the blue sky, leaving a thin, temporary trail in its wake. It flew over the great northern ocean, crossed the coastline, and soared over the vast green grasslands that had been chosen for the first settlement. Its destination was a wide, flat plain, near the mouth of a large, placid river. The craft descended vertically, its engines making only a soft whoosh that barely disturbed the air, and settled onto the thick green grass with the lightest of touches. For a long time nothing happened. The occupants inside were acclimatizing, their bodies and minds adjusting to the final, irrefutable reality of their journey's end. Then a ramp slowly lowered from the belly of the craft, touching the ground with a soft thud. The air of Thea, rich with the scent of grass and river water, flowed into the sterile interior of the lander for the first time. Two figures appeared at the top of the ramp, clad in simple, off-white suits. They wore no helmets. For the first time in their lives, they were breathing unprocessed, planetary air. They walked slowly, hesitantly down the ramp, their eyes wide with a mixture of disbelief and wonder. Their feet touched the ground, not the hard, unyielding metal deck of a starship, but soft, springy turf. One of them, a woman, knelt down and ran her fingers through the blades of grass, then pressed her palm flat against the soil, as if to confirm its reality. They stood, two small human figures in a landscape of immense and gentle beauty. They looked at the vast, open sky, the golden sun, the distant line of trees, the slow-moving river. The only sounds were the whisper of the wind, the distant call of a bird, and the beating of their own hearts. There were no grand speeches, no flags planted. The moment was too profound for such gestures. It was a moment of quiet, overwhelming homecoming to a place they had never known. They had arrived. They were the children of a 1,000-year promise, the beneficiaries of a project of unimaginable scale and patience. They were standing on a pristine world, a new earth, built for them by the long-dead hands of their ancestors. Their long journey through the darkness was over. A new journey, the story of humanity on this second shore, was just beginning. Not with a bang, but with a quiet, meditative breath of clean, sweet air, under the light of a new dawn.